This is now the magnetism and electromagnetism knowledge test. Okay, this is, I've said it numerous times before, this is the minimum amount you need to know for the exam. Right, so what is a solenoid? Okay, so what it is a coil of wire. When you run a current through it, a current through it, that's batting, isn't it? It becomes an electromagnet. Okay, so really what it does, it looks like a spring. You pass a current through it, so you put your current in there, right, your current comes out of there, and what it does, it becomes an electromagnet, and that's a solenoid. Okay, what are the three magnetic elements, right? Iron, Fe, is the most obvious one that everybody knows, but you've also got cobalt, which is also magnetic, Co, and you've also got nickel, Ni. Okay, they're all three magnetic elements. What was a permanent and an induced magnet? A permanent magnet produces its own magnetic field. Right, so it's like one of those bar magnets that you get in lessons, right, with a north to a south. Right, that is then your permanent magnet. An induced magnet is a temporary magnet. Right, so that is then, excuse me, that is then when you get like a little piece of metal, bring it next to the magnet itself, and what it becomes temporarily magnetic, and as soon as you take it away again, then it loses its magnetism. How do I increase the strength of an electromagnet? Okay, so what I've got here is I've got my electromagnet, right, my solenoid. What I can do is I can do a larger current. Okay, so if I put more amps into that, then what happens is it becomes a stronger electromagnet. What I could also do is I could also put in more turns. Okay, so it could be more turns. I could also closer together. So I've got the same number of coils, right, but what I do is I put them closer together. And the final one, and the most important one of them all is put in an iron core, right? So what you have is you can just put a piece of iron in, right, then you put your coil around the outside, and what happens then is it becomes even stronger. So if you're asking the exam, how do I increase the strength of the electromagnet? Right, number one is that, right, unless it's already got an iron core, then what you can do, you can put larger current, more turns, and put the coils closer together. Right, complete the table regarding Fleming's left-hand rule. Right, so I quite like this. When a question comes up on the exam, you see people in the exam doing this and kind of moving themselves around, which is fine. Right, so what I'm going to do here is the thumb is the direction of movement. Now I'm just going to write down the actual kind of wording of it first. The first finger is the magnetic field, and then the second finger is the direction of current. Alright, so that there is the second finger, that there is the first finger, and that there is the thumb, just in case you didn't know. Right, so let's firstly have a look at the thumb. Direction of movement. So if you've got your thumb, right, what you can do is the thumb is then the direction the wire is then going to move. Alright, and what you've got is you've got thumb. Right, so thumb, the muck bit is movement, thumb movement. First finger is the field, okay, so the magnetic field. So first field. And the second finger is then current. Okay, I don't know whether that helps or not. Right, it kind of helps me a little bit, but the M, so the thumb is the movement. The first finger is then the direction of the field, where it's going north-south. And the second finger is the direction that the current would move. So what you'll do is you've given 2, and then what you've got to do is you've got to sit there and look a little bit unusual, right, and then kind of move your hand around a little bit to work it out. Excuse me, I've got a bit of a cough. Right, what is an electric motor? It is a coil of wire that rotates about an axle. Okay, so it's just a coil of wire and literally it spins around on an axle. Question number 7, compare a step-up and step-down transformer. So a step-up transformer, right, which is the one that's right by the power station, what it does is increases the voltage. And really what that is, that's to give it a massive, great big push across the country. So it's got a certain voltage in the power station, and then the step-up transformer gives it a massive, great big kick, all right, and that massive, great big kick then pushes it across the country. The voltage, when it gets to step-down transformer, it decreases it, right? So we don't want hundreds of thousands of volts coming into our house. What we want is the 230 that I am using at this moment in time. Current, it gets decreased, right? And that is the flow, right? So what you don't want is you don't want loads of current flowing, because if loads of current flowing, then that creates issues. And when it gets back down, the step-up, step-down transformer increases the current again. Okay, so there's less current flowing through the pylons than there is potentially into your house. Why do we do this? So what it does is increases efficiency, and it does that by decreasing the heat. So if there's less current, there's less heat that's made, right? And if there's less current, then it makes it more cost effective. Step-down transformer, why do you do it? It is then safer, right? Because the last thing you want is 115,000 volts coming into your Xbox, right? Because you're talking about a lot